Hello, ladies and gentlemen. Today we are going to take a look at trapezoids, isosceles trapezoids, as well as a kite. You're going to need your notes and those little flaps that I gave you, something to write with. A calculator might be beneficial if we do a little bit of example work here, but pretty much we're just going to be writing those properties into those little foldables that we were making, okay? So make sure that you're writing in the appropriate one, and make sure you write all the properties down so that we can use them in class. So let's first start with the kite. The kite is exactly what you imagine it to be. It's this old school picture of a kite. That shape is what we're talking about when we talk about a kite. So this is a sort of a general picture of what would be happening inside of a kite. You'd have these vertices, A, B, C, D. You'd have two diagonals that you could draw through there. And here are the definitions or the properties of what's happening. When we talk about a kite, we're talking about two pairs of consecutive sides that are congruent, but opposite sides are not congruent. So in this diagram, it means that AB, this side, is the same as BC, this side, and AD is the same as CD, but notice that the opposite sides, this longer one across from it is a shorter one, that is not going to be a congruence situation. So we're talking about consecutive sides that are congruent, two pairs of them, but opposite sides are not congruent to each other. Also in a kite, one pair of opposite angles will be congruent. This big angle A here and the big angle C, they would be congruent to each other. Angle B and angle D will be different simply because angle D is sort of stretched out farther down there, and that's going to make him be a smaller angle. All right, now let's take a look at another property. The diagonals are perpendicular. So that means inside this shape we would have 90 degrees happening where those diagonals intersect. And one diagonal is the perpendicular bisector to the other, or of the other, if you will. So one diagonal is cut in half, and that would be this one right here. Those two pieces of this diagonal AC are congruent to each other, where this longer one is not cut in half. You can see it has a smaller portion and a larger portion. Okay, so properties of kites. They are exactly that figure or shape that you think of when you think of drawing a picture of a kite. It's not the dragon or My Little Pony kite that you flew as a kid, but it's this old school diagram of what a kite looks like, okay? The last one we need to fill in for properties, one diagonal will bisect opposite angles. So the diagonal that wasn't being cut in half itself, the smaller and the larger piece, it will cut in half the angles up here at the top. Those two angles at angle B are congruent, and the two angles down here at angle D are congruent. But you can visually see the two angles where this diagonal splits through C, they are not congruent to each other. You can visually recognize that just by the way the shape of the kite is formed, okay? Let's look at a trapezoid now. Make sure that you have just the regular trapezoid flap that you're writing in. A regular or typical trapezoid has some special properties. First, the definition is that you have exactly one pair of parallel sides. So only one pair of sides will be parallel. The other two will be slanted in different directions. And the two sides that are parallel are called the bases. So this is a base, this is a base. The other sides are called legs, if you will. There we go. And it says about the bases, each lower base angle is supplementary to the upper base angle on the same side. So because these are both called bases, an angle made by that base will be called a base angle. So angle D and angle A and angle B here, they will not be congruent, but they will add up to make 180 degrees. They are supplementary. And if you think about that, that's because we have parallel lines, and these would be same side interior, and that property still holds true, okay? For parallel lines, we have one pair in this case with the trapezoid. And the same thing will be happening at angle C here. C is not congruent to B, and D is not congruent to A, so I'm going to put all these little slashes in here. But yet, when I add those two angles, they will add up to make 180. A mid-segment is a segment that connects the midpoints of the legs of the trapezoid. So if I were to draw a midpoint on a leg here, midpoint on a leg here, and draw this line that passes through the middle like this, this mid-segment would also run parallel to the bases. And ironically, or interestingly enough, using the idea of a mean or an average, the mid-segment is in fact half of the sum of the bases. So if this is 10 and this is 12, you would add 10 plus 12 and get 22. Half of 22 is 11. So notice how 10 and then one bigger makes 11, and one bigger than that makes 12. We're talking about that mid-segment kind of like being the average, obviously, of those two bases. Now with an isosceles trapezoid, that's a little bit more special than a regular typical trapezoid, okay? So an isosceles trapezoid is a trapezoid with congruent legs. So that is by definition, it's still a trapezoid, it still has that one pair of parallel sides here, but now these legs are congruent to each other, not parallel, but congruent. Also in an isosceles trapezoid, because he's isosceles now and has congruent legs, some more angles are going to be congruent. The two upper base angles, B and all of C here, will be congruent to each other, and the lower base angles will be congruent to each other, and you can kind of see that's because this isosceles trapezoid has some symmetry here. The diagonals will be congruent in length. That means B all the way down to D will be the same length as C all the way down to A, okay? Diagonals will be congruent to each other. Oops, sorry. And I want to make sure you had time to get all those in there. So notice in this one, though, the diagonals are not necessarily perpendicular to each other. The diagonals are not cut in half. Could we conclude that this lovely segment here is congruent to this one over here? Yeah, likely so, right? Because we'd have an isosceles trapezoid, or sorry, isosceles triangle right up in here. We could also start to say this one right here would be the same length as this one over here, this piece of the diagonal. So there are other things that are happening in here, but we might not necessarily list them as a specific property that only applies to that shape, okay? So I want to thank you for taking these notes on these three shapes. We should be able to work with them then when I see you next and use these properties to solve for missing pieces, okay? Thank you. Kincaid out.